Good afternoon to all of you. Now, in today's session, we are going to discuss about the use of synthetic aperture radar dataset, its interferometric technique for continuous mapping and monitoring of the volcanic deformation, as well as the lava flow mapping and monitoring also. So, here we are going to talk about the volcanic deformation mapping and monitoring with the help of the time series dataset of synthetic aperture radar. So now, as we all are knowing that when we are talking about the volcanic deformation mapping and monitoring, so thermal datasets, they are also very much useful to provide the information of the temperature. Like here, left side image is the Aster nighttime thermal image for one volcano, in which we can easily see that the center at the center we are going to get very high temperature information, because thermal data sets are going to provide very sensitive information related to the temperature measurements. And if you will see the optical multispectral data set, so we can get the information about the structural features of the volcanic mountain, but we are not sure that here from after seeing the data set the volcano is active or not. But from the thermal data set we can say that, okay, since the temperature is very high, so the volcano which is shown here, that is not a dead volcano, there must be some volcanic activity is going on. Due to that activity, the temperature at the center of the volcano, the crater, or the temperature near to the crater, that is very high. So that information we can do with the help of optical multispectral and the thermal data set. Actually, to the clear visualization of the volcanic features or lava flow mapping and monitoring, the thermal data sets and optical data sets, they are also very much useful to identify and to the interpretation of the features. But most of the time, due to the gaseous eruptions and due to the cloud cover, it becomes difficult to do the interpretation of the volcanic features, so that at that time we have the options we have options available with us are of the synthetic aperture radar data only. With the help of that, we can do the mapping and monitoring of these areas, because in the previous lectures you have already seen the different properties of the synthetic aperture radar data set, in which you have seen that due to the penetration capability or the cloud penetration capability of the long wavelengths of the microwaves, they can easily pass through the cloud cover or the gaseous eruptions, and they can provide the information of the earth object very clearly. Now in the next slide we will see the recent eruption of and this is the image of the Copernicus Sentinel-2 mission, which was acquired on 30th September of 2021, when the La Palma lava flow was there, and the lava flow could be easily seen in this Sentinel-2 multispectral data set, in which the red color flow, red and yellow color flow is the basically the lava flow that could be easily detected and that could be easily seen. And not only this, we were able to see that there are some gaseous eruptions also, and those gaseous eruptions could also be seen, and the interpretation could be made accordingly. But most of the time, when there will be gaseous eruptions or due to the cloud cover, it becomes difficult to do the identification of the features. Now, with the help of the SAR data set, one can do the continuous mapping and monitoring. Like this, I took it from the website of JAXA. So this is the LOS pulsar data set of Mount Agung in Indonesia. So this is on the island of Bali in Indonesia, and it erupted 5 times in November 2017. And here you can see that on October 5, 2017, when the image was captured, at that time there was no eruption. So before eruption the image was captured, and here this is the second image, is again a color composite generated from the LOS pulsar data set for the same area, and that image was acquired on the 30th November 2017 when there was volcanic eruptions in the Mount Agong mountain. So here you can easily see that in both the images, if you will see the magma level is down in the first image, that could be easily seen, and during the eruption, since magma level was high, so here you can see that level could also be seen here. So SAR data based interpretation could also be done to understand the level of the magma when the magma level is rising. So when will it start flowing as lava? So the interpretation could also be done to do the continuous mapping and monitoring when the magma level is increasing, or if there will be any explosion. So that could also be detected with the help of optical multispectral as well as the SAR data sets. But if there will be cloud cover or the gaseous eruption at that time, it might be possible that the thermal and optical multispectral data set, they could not provide the clear information of the surface at that time. The synthetic aperture radar data sets could be used to do the interpretation. Now this is another study carried out by Ling Ye et al. In 2018, when a tsunami hit the Sunda state area on December 22nd in 2018. So what happened? So there was eruption in the Mount Anak Krakatoa. So here you can see that in the images, both the images, here you can see that this is the synthetic aperture radar Sentinel-1A data set. And if you will see this data set, so the first data set, this was acquired on 28th December 2018, and the first data set, the top one, is acquired on the 10th December 2018, and after that tsunami, the data set were acquired for 22nd December 2018 as well as the 28th December 2018 by Sentinel-1B. So here you can clearly see that the area is significantly affected, and if you will see in the next image, here you can see that the entire there was complete collapse of the island. Some information is there, but here you can see that due to that event, what was the image of the volcano before the tsunami and after the tsunami. Okay. So now not only this, here if you will see the Sentinel-1 data set, which was acquired on 22nd December 2018. So if you will see it carefully, so there are some information. You can see that water ripples moving away from the volcanic area, that could also be easily seen. So the effect created the water ripples, and that could also be seen in the data set. And the information is published, that is based on the title is InSAR coherence and the backscatter image based analysis for the Anak Krakatoa volcanic eruption. So one can go in detail to find out the more information or the complete information of this area. Now another study which was carried out to show the potential of synthetic aperture radar data set as well as the backscatter and intensity image based interpretation, and not only this, how to use the time series interferometric data set to do the continuous mapping and monitoring of the study area. So if you will see, a study was carried out to do the volcanic eruptions mapping and monitoring. The volcanic eruption of the Hawaii Island, in the Hawaii Island, that started on May 3rd, 2018. So here if you will see the both the images, right hand side, the false color composite image is generated with the help of the synthetic aperture radar data set, in which the the top image is basically the image in which the red color or red band is basically represented by the coherence image, interferometric coherence. We are knowing that interferometric coherence is the a kind of the complex correlation coefficient, very much similar to the complex correlation coefficient, and the coherence, interferometric coherence, will be high for those objects in the two images which does not or which are not going to change with time. So in the two images or in the two acquisition or the interferometric acquisition of the SAR data set, if any stable scatterer is there and that scatterer is not changing with time, so for those scatterers are going to show high coherence. So the layer which is represented in red color is basically the coherence image, interferometric coherence image, that is generated from the 8th April and the 2nd May data set of the Sentinel-1. Now the green band is representing the backscatter sigma naught image of VV channel that was acquired on the 2nd May, and the blue is representing the sigma naught VV for the 8th April. So now here you can see that since at that time no eruption was there, because the eruption started on the 3rd May, so we are not able to see any kind of flow or anything is not visible. Everything is looking normal according to their interferometric behavior or their backscatter behavior. Now when the same area was imaged and the two images, one of the 8th April and another image is of the 13th June. So in that the interferometric coherence of 8th April and 13th June image is represented in red band, and the blue is representing sigma naught VV of the 8th April. So here we are able to see, here you can see that the blue line that is clearly show the lava flow direction, okay, lava flow channel, okay. So with the help of synthetic aperture radar data set, one can easily see this lava flow direction, and its extent as well as the mapping and monitoring could also be done. Now in the previous study which I have shown, that is the article which is published in Journal of Volcanology and Geothermal Research. That article is basically S-bus interferometric analysis for volcanic eruption of Hawaii Island. So when this Hawaii Island volcano that had erupted, so the information of fissures were also there. So total 24 fissures had opened at Lilani Estate, which started as small cracks on the ground, and some of them developed into highly active vents from which the significant amount of lava flowed out. So these total 24 fissures information were provided, and based on this information it also became possible to do the lava flow mapping and monitoring. So lava flow mapping was possible. A model was also created so that one will be able to understand the underground magma movement as well as the lava flow on the surface. So here you can see that the crater Helmamau crater. So over a past few decades, both the craters, like if you will see this crater, the main crater, that is the Helmamau crater of the Kilauea mountain. So and another is the Puo crater. So in the rift zone, it could be seen that, and this was continuously active at that time. So this is Puo crater that is situated 18 kilometer away to the east of this Helmau crater. So and here you can see that this was the model which was given by Garcia et al. In 1996. Now in the 2018 volcanic eruption towards the east rift zone, since this Puo crater was there, and the volcanic eruptions had started. So based on the fishery information, when the modeling was done, so this model was generated. This image was generated, and based on that, one will be able to understand the direction of the magma flow as well as the lava flow also. So and here you can see that the subterranean magma channel has been shown here based on the fishery information as well as the model. Okay, towards the east rift zone, so that could be easily seen here. Now here I would like to show you a comparison. In next few slides, I would like to show a comparison of the optical multispectral data set and the challenges faced in those data set, and how the SAR data set became beneficial in doing the observation or monitoring of the lava flow. So here again another RGB image is generated, in which a red channel is the interferometric coherence image that is generated with the help of the 8th April and 25th June Sentinel-1 data set, and green one is the sigma naught VV, and blue is the sigma naught VV for the 8th April. Now when the same area, so here in this image you can easily see that the lava flow direction could be easily detected, and it could be easily seen. Now if you will see the same area with the help of optical multispectral and Landsat data set, since the area was appearing, the foggy and cloud cover were also there, and some eruptions, gaseous eruptions were also there. So due to that, it was not clear. We were not able to clearly see the terrain surface or earth surface, so or the surface of the Kilwa mountain. So at that time, what we did, we took the two bands of the Sentinel-2 images, band number 2 and band number 3 of Sentinel-2, and what we did, we had taken another band, that is the band number 10 of the Landsat 8, that is the thermal infrared band. So that band we have used and represented in the red color in the this color composite image. Now here you can see that a very good lava flow information is available. So here with the help of this thermal band, even if the no clear information could be obtained from the optical multispectral data set, so by using the thermal data set, one will have more clear information for the area. Here you can easily see. But what will happen when the surface will be surface will have, or the area will be covered by the thick cloud cover? So at that time, even thermal data sets are also not providing very fruitful result, because in the next image here you can see that in the Landsat 8 thermal band and the Sentinel-2 optical multispectral data-based color composite image, again here you can see that there is like no clear information of the lava flow direction. Some information here you can see that, but here no clear information is there. So at that time it will become difficult to do the mapping and monitoring. Again, with the help of the synthetic aperture radar based RGB stack, we are able to clearly see the lava flow direction, and that mapping could be done with the help of this. Now next we are going to talk about the surface deformation mapping. Actually the volcanic eruption was due to the volcanic eruptions here, the several earthquakes were also recorded. So, and there was continuously subsidence in that area. So we tried to map, because like the very famous two techniques are PS InSAR and SBAS. There are other techniques also. Even in PS InSAR also, if you will go in detail, there are several advanced algorithms developed for this. But in this area, it is difficult to get the very persistent scatterers continuously for the in this area. So because the mainly natural features were there. So what we did, we implemented short baseline concept approach. Why? Because this is basically having the short baseline, as well as the due to short baseline we are going to get the high current. So this approach was implemented, and here you can see that line of sight displacement map was generated. One will be able to generate the vertical displacement also by implementing the other approaches. So here you can see, when we the image which is generated here, they are showing the line of sight displacement map with respect to the image which was acquired on the 8th April 2018. So A is showing the displacement till the 2nd May 2018. B is representing the till 14th May 2018, and C is representing till 26th May 2018. Now, if you will see that when we are moving from May within May, like from first week to the last week, end of the May, so there is continuous subsidence occurring. In this image here you can see that in the area, because here you can see that on 2nd May 2018 very less subsidence was recorded, and the area suffered from the subsidence was also very less. But during the mid of May, here you can see that subsidence level increased till near to in between -200 to 400 for some location, less than -400 millimeter were also detected. Okay. Now what happened when we had used the image of 26th May 2018. So the line of sight map, line of sight displacement map, it is showing the for several location the displacement up to -600 millimeter. So the complete information of the detail and some correlation was also established with the help of the quick information, so that you can get in this research article, SBAS interferometric analysis for the volcanic eruption of Hawaii Island. Now this is another study which was carried out by Dr. Scott Henley. So in this study they used the UAV SAR based SAR interferometry to find out the total displacement of the lava flow. So here you can see that the interval between two interferometric acquisition were 4.2 hours, that is approximately equal to 0.174 days. So when the motion was estimated, motion was estimated. So what happened here, you can see that the estimated motion was approximately 0.344 meter per day. But here, since the data sets were required at very short interval, so we are able to find out this motion very efficiently, and very good interferometric pattern are generated that could also be seen here. Now few studies were carried out by me and my team for the Gulf Coast archipelago. So there are several mountains, like not mountains, there are several volcanoes, like Wolf volcano, that is the highest peak volcano particularly in the Gulf Coast archipelago, Farina volcano, Darwin volcano. So there are several volcanoes. So we carried out a study particularly for the La Cumbre Farinana volcano eruption, and tried to do the subsidence mapping and monitoring as well as the lava flow mapping. So when we are talking about the Galapagos archipelago, so there are total 19 islands, and the surrounding marine reserve have been called a unique living museum and the showcase of evaluation. And this is located at the confluence of the three ocean currents. The Galapagos are a melting pond of the marine species. So here you are always going to see that the volcanic activities will be going on. So ongoing seismic and volcanic activity reflects the processes that form the islands. So these processes, together with the extreme isolation of the islands, led to the development of unusual animal life such as the land iguana, the giant tortoise, and the many types of finch that inspired Charles Darwin's theory of evolution by natural selection following his visit in 1835. This information I got it from the UNESCO website. One can follow and they can also get this information. So we tried to generate the interferometric phase for this area because Sentinel-2 time series data sets were available for this area, and when we got the information about the volcanic eruption of the Farinana volcano, so we were motivated to carry out a study for for knowing about the subsidence as well as the lava flow. And here if you will see that there are two earthquake stations are also there. So one will be able to correlate the volcanic eruptions triggered by the quake also. So these things could be done, and the several literatures are also there, and we also try to carry out a study for these volcanic areas. So when we carried out a study particularly for the La Cumbre volcano, so here you can see that this the volcanic eruptions, here you can see that recently also it had erupted, but we are here mainly focusing about the three eruptions which were there in 2017, 18 and 2020. So particularly for 2020 only we carried out the InSAR based analysis. Now here you can see that the yellow color here which you are seeing that this is the lava flow which came out due to the volcanic eruptions which was in 2017, and the orange color is in another direction here, and this is due to the volcanic eruption in 2018, and for 2020 it is represented in a red color. Okay. Now if you will see that one thing is very much obvious, that eruptions are not in a particular directions. Okay, and if you can clearly see the other in like other portions of the this area, this is basically the Sentinel-2 image. So if you will see in this area, so you can see that there are several other eruptions also, but those eruptions are in like previous years or in last previous decades. You can see that these eruptions were there, and our study is mainly focused on the eruption which was there in 2020, that is shown in the red color. Now if you will see that the two stations are established there. So there here you can see this is the stations are basically established by IGEPN. So they on the website you will have the continuous information if there will be volcanic events in this area. So you can get those readings from the portal maintained by IGEPN. So here if you will see in the graph, so graph showing the root mean square amplitude of the seismic signals from the station 1, that is named as the FER1. FER, they have given the name based on the Ferdinand Island, and FER station at Ferdinand on 12th and the 13th January 2020. Now the graph shows the increase in the seismicity leading to the eruption on the 12th, the left star which is shown here. A decrease in the seismicity and then another decrease during the event right side that could be seen. Okay, so here some correlation was established with this, and the study was carried out, and the time series changes were detected with the help of the Sentinel-1 data set. So here also SBAS based analysis. SBAS is basically an extended form of different or advanced technique of differential SAR interferometry. So in this literature, SBAS InSAR analysis of January 2022 eruption of the La Cumbre volcano of the Galapagos archipelago, we carried out a study, and which has been published in Journal of Applied Geophysics. So in this study here, you can see that line of sight displacement map was created, and here you can see that the displacement could be easily seen during the time of eruption. But here if you will see that when the eruption had stopped, so at that time we are not getting, or very less changes we are getting, approximately negligible line of sight displacement we are getting from the data set. Now this is the time series analysis. We have established 3 pins at the near to the volcanic crater, near to the caldera also. We created 3 pins, and we did the time series analysis about the subsidence for these 3 pins near to the caldera. And in the image here you can see that the 3 pins are represented here in the red, green, as well as the in the blue color. So red, green, blue, these are the locations of the 3 pins. And here you can see that the pin 1, here you can see that the subsidence is up to minus 150 only, and then it is going down. So but here if you will see particularly towards pin 2, and when you will correlate it with the time series graph, so towards pin 2 there is high subsidence could be detected, and that was verified with the values for the pin 2. Here you can see that in pin 2 we obtained till minus 450 millimeter subsidence. Okay, and here also when the time series map was generated for the entire Galapagos archipelago, basically this time series map was generated with the help of the SBAS interferometric processing of I think HYPE 3 that was maintained by Alaska Satellite Facility, ASF. So in that we processed, and finally when this time series map was generated, so here you can see that when the time is increasing, the line of sight displacement is also increasing this volcanic area, particularly in the Ferdinand Island. But at the same time when there is increase, here you can see that the some effect could also be seen towards the another side, another volcano is there, that is also seen. So it means that some activity, volcanic activity was also going on here. This was not erupted, but some movement was also there, because it has been found that the different volcanoes of not different volcano, we can say the several volcanoes of the Galapagos Island, they are magmatically connected to each other. So it is also possible that even there will be any activity going on in one area, the effect could also be seen in the another area. Now this is the another study which is available on USGS. With the help of the Sentinel-1 dataset, a study was carried out. A time series change was detected for Krushov Island for August 2018 through April 15, 2023. So a deformation rate basically that could be seen here, and the flight direction in the ascending path, the direction is represented here. So here you can see that the deformation increased closer to the northwest flank of the mount. From this data set it is clearly visible, and the inflation rate was approximately 10.4 centimeter per year in the line of sight direction. Okay, and here you can see that from 2018 to when moving towards 2022 and 2023, here this could be easily seen that the changes could be easily seen here. Okay, so with the help of the Sentinel-1 dataset, a displacement could be easily seen. Either displacement will be in positive direction or negative direction, that displacement could be seen. Now these are the few studies which we carried out here, like SBAS-based interferometric analysis for the volcanic eruption of Hawaii Island, and then SBAS and INSAR analysis of the January 2020 eruption of the La Cumbre volcano, and INSAR coherence and the backscatter based analysis of the Anak Krakatoa volcano, and the PNSAR processing for the volcanic ground deformation monitoring over Fogo Island, and DINSAR based analysis of January 2022 eruption of the Ferdinand volcano Galapagos. So these studies are available by our team. So if one will be interested in going in detail of mapping and monitoring of the volcanic eruptions, so they can go in detail using these literatures, or if they are interested they can contact me also, because we are currently working with several other volcanic mapping and monitoring. Thank you for attending this lecture. Now very soon we will start our question answer session.